so in exercise 1 we have to account for which graph is the function of f and which graph is the derivative of function, so the f dashed. So in this example we can see that here b is decreasing, and while b is decreasing, a is below the x-axis, which is here, you can see. And here b starts increasing, and here a goes above the x-axis. And then we have the stationary point of a right here, stationary point of b down here. And then we can see that here b starts to decrease and a goes below the x-axis, and then we have the stationary point b right here where it stops. Yeah, so that's basically it. So b is the function f, meanwhile a is the derivative of f.
Alright, for exercise 2, we have the function f of x equals the natural log of x minus 0.2x plus 3, and x is greater than 0. So the question, or exercise A, is find f dash of x and account for the significance of f dash of 1 equals 0.8. So to be able to differentiate the natural log of x, we say f dash of x equals natural log of x, which then becomes f of x equals the natural log h of x, which we then can differentiate by saying f dash of x equals h dash of x over h of x. And this enables us to differentiate the natural log of x. So we can do that now by taking this function and dash it. Differentiate it. So f dash of x equals h dash of x over h of x, which then becomes 1 over x as x dash becomes 1, and then this just stays x. And then minus 0.2x, which then becomes 0.2 because of the power rule, as this is to the power of 1 times 1, which becomes 0.2, easy, minus 1, then just becomes minus 0.2, as we have the minus here, and then plus 3, and as this is a constant, it becomes 0. Goodbye. And this means that our dash function is f dash of x equals 1 over x minus 0.2. And if we account for the significance of f dash of 1 equals 0.8, we put 1 into our function here that we dash. So f dash of 1 equals 1 over 1, which is 1, minus 0.2, which is equal to 0.8. And this means that this statement is true, that if f dash of 1, if f dash of x is 1, it is equal to 0.8. Alright, so for exercise 2, part B, we need to find the monotonicity of function f. And we do that by having the derivative of our function f and finding the 0 of it. And we do that by replacing f dash of x with 0, and then we solve for x. We say 0 equals 1 over x minus 0.2. Then we say plus 0.2, so we get 1 over x on this side and 0.2 on this side. And then we times with x, so we can have it alone. So x over x becomes 1, and then we have 0.2x over here by itself, and then we can solve for x now, because 0.2x equals 1, so we times with 5 to be able to calculate what x is, and x is equal to 5. And now that we have this information, we're able to put it into our assign table to find the monotonicity. Thank you. Alright, so for the interval we have 0 is less than 5, and x is equal to 5, and 5 is less than x, and x is less than infinity. So we put in the test value for 1, and we sign it into the f dash of x. So f dash of 1 is equal to 1 over 1 minus 0.2, which is equal to 0.8. This is positive. This means that we have an increase, positive increase. We have a positive monotonicity at this interval. Then at x equals 5, we plot in 5, so f dash of 5 equals 1 over 5 minus 0.2, which is, we say, for this interval, we have the test value of 10, so we put 10 in here, so f dash of 10 equals 1 over 10 minus 0.2, which is equal to minus 0.1, which means we have monotone decrease because it's negative.
I would like to show you a little about the company Syncraft. The company here has a, you can see here a cost formula. This says that 0.02 x to the power of 3 minus 4.2 x to the power of 2 plus 480x plus 11,890. So this is the cost formula, and of course they have to produce more than 0 like units, and this is per week in liters. And the company can sell their product for 600 kroner per liter. So here down we see the revenue formula. Here we see that, of course, that for every unit they produce, liter, they get 600, and they have to produce more than 0. They cannot produce minus. And task A is find the production quantities of the chemical making cost and revenue equally big. So we have here the whole geography, and the one you see here is the cost. You can see here the long formula, the first one I read, and the second red here is the revenue. That is just 600x, and you can see we have to find out where they equal each other, and that is in point A here. You can see the number here in 44.49 units, and point B here in 224.92 units. So yeah, that is task A. Hi G, I will now do task B, and in task B we need to find the profit at a production of 150 liters for this company. So it is, we take the revenue minus the cost formulas here, and that is the line we got down here. So this line is adjusted, and we need to find for 150 liters. So you find 150 here on the x, and you go up here, and it says that on the y-axis that is the same as 33,110. So that is their profit for 150 liters. G, I will now do the final task, and it is task C. You can see here it says find the maximum profit the company can obtain per week by production of the chemical. So if you look at this graph, you can see that this is a profit line, and we want to find this top part of the profit line, but it's kind of hard to tell by just looking at it. But we can find it here by writing this, and it's the H line, and we write the 2 points, and 92, and we end it, and here you can see the new one that popped up was 153.07, and that means that by producing 153.07 units, we get the maximum profit for this week.